what exactly the descriptive statistics mean, and the practical sessions using Python and Excel. Without delay, let us go ahead and understand what is statistics. Statistics is the study of data. It helps in describing the data and drawing insights about the data. So what do I mean exactly by this? Let us assume that we have a data related to the customers or sales associated with one particular store. Whenever the sale is happening, the store would like to capture the details about the customer name, the age of the customer, and the items purchased by the customer, that is the name of the items purchased, and the number of items purchased. What is the cost of each item and the total cost. Let us assume this is the data which is being captured by a store. Whenever you look at this particular data here, this clearly describes that it is a sales data related to a particular store. And the moment I give you the customers data of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 customers data, and the number of items purchased and the name of the items purchased, what it does is it says that the customer one name is Alex, his age is 28 years, and he has purchased Apple chocolates. And the number of purchased accounts to. The cost of each item, the apple costed around 40 rupees and the chocolates costed around 20 rupees. The total cost associated is 60 rupees. So if you just look into this particular data, what it is doing is, you are studying the data and you are drawing some insights. Now probably if I just give you the details of all these 10 customers, we can extract an insight saying that which age group of customers purchased what kind of products or items. We can also understand that the second one is, what is the highest sale that has happened or what is the highest total cost, and which customer has made the highest total cost. We can also answer one more question saying that which customer has bought maximum number of items. So if you just look at these three questions, at the very first step, I have described the data. How did I describe the data? By naming the columns. And the second thing, I have drawn some sort of insights over here by looking at this data. So these are nothing but your insights. So this is about the statistics. The statistics is one which helps you to describe the data and helps you to draw some sort of insights by looking or by understanding the data. Hence, statistics captures or statistics has two branches. One of the branch is the descriptive statistics. The other one is the inferential statistics. Now, what does the descriptive statistics talk about? Now, descriptive statistics talks about the describing of the data. So till now, in the previous example, whatever you have seen is nothing but the description about each and every column. So indirectly, what it is saying is, it is giving you a thorough understanding of the data. So hence, the very first characteristic of descriptive statistics is to understand the data. The second one is, as we have seen in the previous example, we try to draw some sort of insights by looking at the data. The moment you understand the data, so what you do here is, you try to draw some sort of insights by taking a combination of the columns or by looking at one particular column or to find out the relationship between the two columns. Now the third one is, whenever you are drawing the insights, so generally what we do is, we represent the number of items bought either in a visual format by using some sort of graphs or pictorial representations. That is nothing but your visualizations. So in the visualizations, we use charts, graphs, or any other visualizations to represent the data. So descriptive statistics hence talks about what is known to us. In the previous example, if you just look into the same example which we have discussed over here, it talks about what is that we know. I know that Alex has purchased 2 items. I know that the total cost of the Alex has made is 60 rupees. Now the same thing we are going to represent in a graph format, in a chart format, or in any visualization format, then it is called as a descriptive statistics. Now coming to the inferential statistics. So inferential statistics talks about inferring something. What is that you have inferred? What is that you are able to arrive at? What is that you can conclude at? Right? Is nothing but your inferential statistics. So inferential statistics helps you to test certain hypotheses. Inferential statistics helps you to test some sort of assumptions, or it helps you to test some sort of claims. So whenever it comes for the inferential statistics, it also gives you the statistical significance to come to a conclusion. So what do I mean by this? If I just take the previous example of a sales data, I come up with an assumption saying that customers who are at the age group of 25 to 30 years purchase more number of items. Now this is what I wanted to test. This is what the claim I'm making by looking at the data. Or else I can also say that the second type is, as the number of items purchased is more, the total cost is more. I wanted to test this. Right? So these are the two assumptions, or these are the two insights that are being drawn by looking at the data. Now these assumptions can be tested by using hypothesis testing. Now, in order to go ahead with hypothesis testing, we do have multiple hypothesis testing tools or statistics which are being involved to test the claim depending on the size of the sample. So hence, inferential statistics gives you the statistical significance about the measurement which we have considered. So these are the two important branches of statistics. And the next section, we are going to learn in detail about what is descriptive statistics and what are its functions. Till then, happy learning. Welcome back to the session on descriptive statistics. In this session, we are going to learn in detail about the descriptive statistics. Let us try to understand what descriptive statistics is. In the previous session, we have learned that descriptive statistics helps us to understand the data. That means we are diving deep into the data over here. You are trying to analyze the data. It gives you the summarized results. It represents the entire data. Whenever you are able to describe the data, understand the data, summarize the results, and go give a break for further analysis, then it is called as descriptive statistics. Moving ahead with the understanding of descriptive statistics with an example. Let us assume a college is going to capture the details about the number of students who are being enrolled. As you see here, you have the data about the 10 students who are enrolled for the PhD program. And if you see here, there is a representation of this particular data over here in a bar chart format. If you see here, it is the first student, in the first instance where you have got around 12 people enrolled. At the second phase, you have got around 20 people enrolled. At the third phase, you have 40 people. At the fourth phase, you have 50 people. At the fifth phase, you have around 50 people. So like this, right? So, sorry, 25 people. Like this, if you see here, what is happening over here is the same data is being represented over here, but in a chart format. There is nothing new over here. Whatever is known now by looking at this particular table, if I ask you at which phase do we have more number of enrollment in the fourth phase, the same is being captured over here in the chart. Right? So this is called as descriptive statistics. By looking at this graph, I can ask you, tell me at which phase do we have least number of enrollments? It is at the phase 1. So if you see here, in the entire example, what is that you are trying to do here is, you're trying to understand the data, you're trying to represent the data in a graphical format or in a charts, and you are trying to analyze the data by raising out certain questions. This is how the descriptive statistics is. Now, there are certain tools, there are certain statistical measurements which are used to measure or summarize the data over here. And hence, the descriptive statistics has two different types of measurements that involves. The first one is called as measures of central tendency, and the second one is called as measures of dispersion. Now, these are the tools which are used to measure the data here. Going ahead in understanding what does the measures of central tendency mean. By the words, it is being understood that measures of central tendency is nothing but the central value. So these define the central position of a frequency distribution of the data. What do I mean by this? For example, if I just take the same example which we have discussed in the previous session of the number of students enrolling at the 10 different phases of the interview process or of the counseling process, we understand that if this is how the data looks like, so 1, 2, 3, 4, 5, just for our understanding, I'm just taking it arbitrarily, nothing else, 7, 8, 9, 10. If this is how it is, so for example, let us assume that this is for the year 2021-22, this is the phase of counseling which has happened at 10 different phases, and we have got the number of students enrolled over here in one particular format like this. Okay, so let us assume, okay, this is how it's been captured. Okay. If this is the case, what I can do is I can ask her a question saying that, tell me, what is the average enrollment for the academic year 2021-22? So what we have seen the frequency distribution here, but by looking at the frequency distribution, we are centering down to one particular value, which is nothing but your average. And the same way, I can centralize or I can extract one particular central position based on this particular data. So hence, this is called as a central tendency. There are various measures of central tendency. There is mean, median, mode. I can find it out what would be the median enrollment, which is above and below. So we'll be learning about this mean, median, and mode in detail in the further session. So mode is nothing but how frequently the most occurring word or the most occurring number in the very layman terms. So these are the various measures of central tendency what we have. In the next session, we'll be learning about the measures of dispersion. Till then, happy learning. Welcome to the session on measures of dispersion. In the previous session, we have understood what are the measures of central tendency. In this particular session, we are going to discuss about introduction to measures of dispersion. Going ahead with this, measures of dispersion, the name itself says it is talking about the dispersion, which is nothing but the spread of the data. It gives a representation about how far the data points are from the central value. What do I mean by this? For example, if I have the same example which we have discussed in the last session, that is the sales data with respect to the number of items bought, where the columns were the customer name, age, number of items purchased, cost of the each item, and the total purchase cost. So if this particular data is being given, what I will do is I will first ask you one particular question saying, what is the average purchase made by all the customers? So what am I doing here? I'm cutting down this particular data to a central value. Let us assume the average sales are somewhere over here. Let us understand that it is somewhere around 25 items are being bought, for example. Right? If the 25 items are being is the average, obtained, so average is equal to 25 items. So obtained by taking 100 customers, by taking a sample of 100 customers, then if Alex is a customer, what is his sale? Is he nearer to the average or is he far away from the average? Now, in such a way, if at all, if you just keep plotting the 100 customers data over here, it just gives you the spread of your sample. That is nothing but how far your customers are when you look at your central value. So hence, this gives you about, or this tells you about the distribution of the data. This will also tell you that what is the variation of each customer when looked at the central value, when compared to the central value. Hence, the measures of dispersion is also called as measures of variability. Now, in order to measure this distance, or in order to measure this particular spread, we do have different measurements. Now, those measurements of dispersion include standard deviation, mean deviation, quartile deviation, and variance. These are the different measurements which are being used to understand the spread or to understand how far your data points are when compared to a certain value. So, hence, this talks about the distribution too. In order to understand the concept of measures of dispersion, let us take one more example. The average score of 100 students of a class may be 65. So that means the moment I take 100 students' data, the average value is found to be 65. However, not all the students will have scored 65. There might be the students who are nearer to 65. There might be the students who are far away from 65. So this is which helps you to find it out the lower to higher or higher to lower. This is example of measures of dispersion. In the further sessions, we'll be understanding about these measures of dispersion in detail. So then, happy learning. Having seen the understanding and the measures and the tools which are used to measure the measures of central tendency and the dispersion, in this particular session, we are going to learn in detail about how to calculate the mean, or which is also called as an average. Now, moving ahead with this, we know that mean is one of the measures of central tendency. Hence, it gives you a centralized value. Mean consider the extreme values and gets affected. I'll come back to this point in a meanwhile. It is used for discrete and continuous data, which is being captured in the form of a raw data. The formula that is used to calculate the mean is the sum of observations by number of observations. So hence mean is equal to summation of x by n, where n stands for the number of observations. Generally, mean is being denoted by x bar, which is being pronounced as x bar, right? Which is nothing but the sum of observations by the number of observations, total divided by the number of observations. Now let us go ahead and understand this particular concept so that I'll come back to the point 2 where it gets affected with the extreme values. Let us take this example. I wanted to find the average score of the 10 students based on their marks obtained in the subject of statistics. Now, when I just look out the marks obtained by these 10 students, this is how the marks are. So the first student has got around 35 marks, second student has got around 40 marks, third student has got around 50 marks. Now, how to calculate the average on this? The formula says that average, which is nothing but your mean, is represented with x bar, and the formula is the sum of the observations by number of observations. So which is nothing but x bar is equal to, I have to add all these marks, that is 35 plus 40 plus 50. That means I need to add upon all the marks obtained by all these 10 students, right, and divide it with 10. I arrive at one particular value over here. Now this particular value, which explains or which gives you, is nothing but your mean value. That is nothing but your central value. Now let us go ahead and understand. How can we extract the mean value? You can use the calculators and simplify this particular question. Okay, following up with this, now in this continuation session, we'll see how to calculate this mean value on Excel right now. So moving into this Excel part right now. Now, I wanted to obtain the mean of this. So what do I require? I want the mean. So there is an inbuilt formula to calculate the mean in Excel, which is nothing but the average of whatever the numbers we wanted. So select all these numbers and then close it. Press enter. You'll be getting 63.9. That means the average score of all the 10 students in the subject of statistics is found to be 63.9. Now, if you just take the student 1, he is less than 63.9. Student 2 is less than 40, is less than 63.9. That means here it is giving you the central value and it is saying that the student 1 is far away from the mean value. So this is how we understand about the mean. So if you just take out of 10 students, if you just take this 10 students, the average score made by this 10 students is going to be 63.9. Now, having an understanding of this, mean score, now let us go ahead and take the second example. I have captured the salaries of the 20 workers. I just wanted to see, or I'll calculate the mean value and then see whether the mean is a good measure for me to evaluate the salaries. Now, to understand this, I'll go to the Excel sheet. I've captured the salaries of the 20 customers. Right? What is it I wanted to do? I wanted to calculate the mean value. So I'm doing the same process right now, which we have done for the previous exam. So mean, which is equal to the average of, so the moment you type average plus stat so that it gets selected, okay, capture from the numbers itself, don't capture the labels part, okay, to the exact of this, and close the brackets. Enter. So what is the average score here? 24.9. So that means if I just look at the average salary of this customer, the average salary of this customer is found to be 24.9. But if I look at this particular data thoroughly, okay, I could see that most of the customers, see here, this customer salary fall between 30, right? So 15 to 30. 15, 18, 16, 18, 18, 20. So most of the customer salary falls between 15 to 30. But my measurements are giving me something else, that is 24.9, which is towards the extreme end. Right? Now, the moment I change this value, for example, instead of 15, let us assume that the salary of this particular worker is 95. Let me change this. So my main value is getting changed. That means the moment you have larger values, let us reduce this to 16 and 16 right now. See, the moment I change this, my values are coming in between, right? So that means as and all you have the extreme values, your average will get affected. For example, let me give this as 90, 98, and 95. See, 33. But whereas most of my salaries fall between 15 to 30. If I just change this 90 again, see 36.3, that means if I just see that most of my customers doesn't fall over here, my workers doesn't fall over here in this average salary. So that is what the second point in this particular description talks about. Now, it says that the mean considers the extreme values and gets affected. This is one of the drawback of the mean here. Now, to answer our second question in this particular example, do you think that mean is a good measure to evaluate the salaries? Now, if I just look into this particular Excel part right now, if my values are like this, mean is not a best measure because most of my values are falling between 50 to 30, whereas my average score is coming to 36.3. So hence, this is not the right measure. Then what is the right measure? So we have something called as the other measure of central tendency, which is called as median. We will be looking into the formula of the median, how to calculate it in the next session. Till then, happy learning. Now let us talk about median. Median is nothing but the mid value. When the data is arranged either in descending order or ascending order, the middle value is considered to be as the mid value. Let us calculate the median value of the following data. If this is the data which has been captured, so what we need to do to calculate median is arrange the data in a descending order. So I'll be arranging it as 10, 10, 12, 14, 16, 19, 22, 23, and 28. So the mid value, that is, if I just leave out these 4 observations here and if I just leave out these 4 observations here, the middle value, either by arranging in ascending order or descending order, will be the median value. Now, for this particular data, the median value is found to be 16. So generally, the shortcut to represent the median value is MD. Now, you may get a question. Now, what if, as there are odd number of observations, I can find the mid value? Now, what if I have a even number of observations? Let us take this particular example right now. So this has even number of observations. If you see here, the number of observations would be 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, we wanted to find what would be the median value for this particular observation. As usual, as we have studied, arrange the data either in ascending order or in descending order. After arranging the data in either an ascending or descending order, just try to find it out what are the middle 2 terms. Now take the average of the middle 2, that will be your median value. That is, it is somewhere around 36 by 2, so 18 is the mid value or the median value. This is how we calculate the median value. Now, why we were discussing about the mean calculation with respect to the salary data, we have seen that whether mean is the right measurement because, let us go to that data right now. Yes, if you see here, this is the data what we had, right? We had the workers and the salary, and we wanted to find out whether this is the right measurement, whether mean is the right measurement, and hence we came to a conclusion that mean is not the right measurement. Now let us go ahead and calculate or find it out whether median would be the right measurement to calculate it. So let us see how to calculate the median right now. Median is equal to, so if I just type median, it gives you the median. Select all this, enter. So the median is found to be 25. It makes some sense because what I can say here is, by looking at the median value, I can see that the mid value is 25. I do have workers who fall above the median value and who fall below the median value. So this is how we calculate the median. Now, coming back. So median is the one which gives you the middle value and it gives you the number of observations falling above and below the median value. In the next session, we'll be learning about the mode. Till then, happy learning. Let us try to understand the mode calculation right now. We have seen the measures of central tendency of mean, median, and now we are going to discuss about the mode. Mode is nothing but the most frequently occurring value. Generally, we use histogram or bar chart to represent the mode value. Of course, we also use histogram and the box plot to represent the median and the mean. Later in the post sessions, in the next session, we'll be discussing about the data visualizations, and there I'll just exactly tell you which visualization will best fit based on the measures of central tendency and the dispersion. So generally, mode is generally used on a categorical data. Now, let us try to understand what we mean by this. For example, let us assume that I have the runs scored by a player at 10 matches. Okay. In the first match, he has scored around 20 runs. Second match, he has scored around 45 runs. Third match, he has scored 50. Fourth match, he has scored 35. Fifth match, 37. Sixth match, 42. Seventh match, 50. Eighth match, 48. Ninth match, 50. And 10th match, 50. Now, if you look at the scores of his runs on all the 10 matches, right? What is the frequency? That is how many times, what are the runs that he has made for more number of times? It is 50 over here, 50 over here, 50 over here, 50 over here. So this is your mode value, which is represented with MO. Let's understand the mode with respect to the calculation on Excel right now. So just see here, let us assume I do have different types of transports and I wanted to see the number of customers traveling over here. Generally, I said that we use the chart to represent the mode, right? If I just take a bar chart here, yes. The more number of customers are traveling to bus, right? So this is your mode calculation. Or else if I just go ahead and take the same, the example of match and the runs made, if I just take, 10 matches and if I just calculate the runs scored, and if I just want to calculate the mode value here, I'm calculating mode. Yes, you have to, take this and select this. Yes, you can see 50 has occurred. Even in our data also, it has occurred for 4 times, right? So hence, this is the mode value. This is how we calculate the mode here. Now, having an understanding of how to calculate the mode, let us see what are the key takeaways of this particular session right now. The key takeaways are, there are 3 measures of central tendency, that is mean, median, and mode. They are the central values. Mean is the average score and gets affected by the extreme values. Median is the mid value or the midpoint or the middle value. Mode is the frequently occurring value. In the next session, we will be talking in detail about the measures of dispersion. Till then, happy learning. Measures of dispersion. Measures of dispersion are being classified under 2 heads. The first one is the absolute measure of dispersion. The second one is the relative measure of dispersion. Absolute measure of dispersion measures how spread the data is, or how the data is being scattered given a set of observations, or how far away by taking the distance in order to see how far away the data points are. So we take the distance over here, right? So you are going to measure it on an absolute number by calculating the distance. So hence that determines the absolute measure of dispersion. And the measurements which are used to define the measures of dispersion based on the distance are range and quartile deviation. Coming to the relative measure of dispersion. Relative measure of dispersion is expressed in the terms of deviations. That means how deviated the value is. Like the measures of dispersion for the relative measure falls under two heads. One is mean deviation and standard deviation. In the next session, in the continuous sessions, we are going to talk about these measures of dispersion in detail. Moving ahead with the very basic and the representation of measures of dispersion, range, interquartile deviation or interquartile range, or standard deviation, the median, mean deviation. Okay, so looking at the range right now. Now, range is the very commonly used measure. It is a simple measure to calculate, and it gives you the difference between the maximum value and the minimum value. So range specifies the formula to calculate the range is given by, if at all, if you have a set of numbers, that is x maximum minus x minimum. It's a very simple calculation. So hence, if you have a set of numbers, find out what is the maximum number, find out what is the minimum number, and just take the difference of the two. So hence, that gives you the range value here. Now, when it comes for a range, it's a very simple calculation. Now, going ahead for the quartile deviation. Quartile deviation is used to identify the outliers in the data. That means it tells you how far away your data points are. So hence, in order to identify, I'll be just explaining you what do I mean by this quartile deviation in the meanwhile. So hence, to deal with this quartile deviation, the data whatever we have will be divided into quartiles. The second quartile, which is being represented as Q2, is called as the median value. The first quartile is being estimated, which is between the median value and the smallest number, which is being represented with Q1. And the third quartile is the value between the largest and the median value. So hence, whenever we are dealing with the quartile deviations, we do have the quartiles Q1, Q2, and Q3. Where Q1 is the first quartile, Q2 is the second quartile, which is nothing but the median, Q3 is the third quartile. Now, what does this help us out? So this is a formula to calculate the quartile. So Q is equal to half of Q3 minus Q1. Now, what we do here is whenever we look at the quartile, so the best way to visualize this quartile deviation is by looking at the box plot. Or this is also called as box whisker plot. Now, how to obtain this plot? If I do have a set of observations, what I do is I will find it out, the observations. I'll find out the Q2 value. This is my Q2 value, which is nothing but my median. So from this is what my Q3 is. This is what my Q1 is. Now, how far away the data points are from this? So this is called as a whisker. Right? So hence this measurement is called as a box whisker plot. If the data points are lying within this particular box, then it is normally distributed and there is no outliers. So if the data points are falling somewhere here or here or here, so these are called as outliers. Okay. So this is one of the visual representation what we can give it for the quartile deviation. Later in the data visualization chapter, we will be looking into how to obtain this box plot or the box whisker plot to identify the outliers in the data. Now, the key takeaways. So we have learned two concepts right now. One is the range, which is nothing but your x maximum minus x minimum. And the second one is the interquartile range, or which is also called interquartile deviation. So which is nothing but your quartile deviation, which can be used to identify the outliers and distribution of the data. Now, if you want to see how the distribution of the data would be, for example, in the same box whisker plot, let us assume that the data points are lying over here. Okay, if I assume a bell-shaped curve out of this, so your data is spread across the median. If this is how it is spread out, then we say that it is normally distributed. And generally, the values out of this will be your rejection values, or nothing but the outliers in the data. Right? So this is how we calculate or we represent the quartile deviation. In the next session, we will be learning about the standard deviation, which is one of the important measures. Till then, happy learning. Let us go ahead and see how to calculate the quartile deviation on Excel and how to look at the box plot. Now, moving ahead with this calculation of quartile deviation, I have the data of the students and marks obtained by the students. I wanted to find the quartile deviation value here. There is an inbuilt function to calculate the quartile deviation, so which is equal to the moment I type the quartile, take the last of the function is available to compatible with Excel and returns the quartile of the data set. Okay. So the quartile of these observations. Okay. I have to specify, how many quartiles I need to. So I have to specify whether I want the first quartile, the second quartile, or the third quartile, right? So I'll just mention the first quartile right now. It is my second one, right? So let me enter this. So it is 52.5. So this is my first quartile value. Now, similarly, what we can do is I can also obtain the second quartile value. So the second quartile is equal to the quartile function of this particular data points, comma, the second quartile. Right? So the third quartile value is equal to the quartile of all the observations, comma, 3. Right? So these are the first, second, and second quartile. I said that it is nothing but your median value. Right? Let us verify whether it is fetching the median value or not. I'm calculating the median. Yeah, median of all these observations. Yeah, see, the second quartile is nothing but your median. So this is how you can calculate the quartile deviation. Now, I also said that the quartile deviation is used to identify the outliers in the data. Now, what do I mean by outliers? Now, if I just look at this particular column of the marks obtained by the students over here, most of the students marks range between the maximum value. So if I just look at the range here, okay, how to calculate the range? So it is the maximum of this minus the minimum value of this, which is 63. So here, if you see here, the maximum value is actually 98, right? So hence it is 98 minus, if you see here, the minimum value is 35, right? So let me color this. So the minimum value is 35, right? Now if I just take the difference of this 2 minus 35 is 63. This is how you obtain the range. This is how you obtain the quartile deviation. But if you look into this particular data, 98 is a very highest value. So he is the only student who has got the marks of 98. So what did I tell you? Whenever we are dealing with the interquartile range, so it helps you to find it out the outliers in the data. So one of the ways to find outliers in the data, so as the data is very small, you can identify that 92 as an outlier or the very maximum value, right? Where other data points might not fit over here, right? If you have a large volume of the data, it will be very difficult to identify. So hence what we do is we try to visualize the data here. So how to do that? How to get the box plot? You just go to here, select the data, go to insert, and if you just go here under the charts, you will be seeing something called as box whisker plot. Yes, box and whisker plot. So I just plot it over here. Okay, so it is saying that there is one value which is lying over here, which is far away data point. And of course, we'll try to do the same thing. So it says one data point is far away, right? So we'll try to extract the same thing by using Python. Okay, so this is how you can visualize the data for with a box whisker plot. So there is one data point, right? So this is about the calculation of quartile deviation. In the next session, we'll be just moving ahead and understanding how to calculate the standard deviation. Till then, happy learning. Welcome to the session on calculation of standard deviation. Standard deviation is the square root of the variance. Variance is calculated by considering the arithmetic mean of the squares of the deviations of given values. We will be understanding this in the meanwhile. So hence, standard deviation is always represented with sigma. So the square root of the variance gives you the standard deviation. Now, let us go ahead and then see how this, the formula is being used to calculate. If I know the average variance, how far my data points are from the mean value, that is, if I just take the distance between these two and square it out and divide it with n by n minus 1, where n stands for the number of observations, okay, then we will get the standard deviation. Now, let us go ahead and see how to calculate the standard deviation using Excel. Now, to go ahead with this, let us consider the same example where we are just looking at the marks scored by the students. Now, on this, I wanted to calculate the standard deviation. So, how far my values are from, so standard deviation, the function is available and based on, okay, logical value. So, if I just take the same, yeah, so the standard deviation value is found to be 18.93. Now, if you just take this first student, so he is, if you just see here, he's 35 and he's 18. He's little deviated from the deviation value. The deviation value is higher. If it is 40, the deviation value is still more higher. So like this, we'll find the standard deviation by using Excel. Now, if we just go ahead and then look into what is the mean deviation. Mean deviation is used to calculate the average deviation from the mean value. The formula used to calculate the mean deviation is summation of modulus of x minus mu upon n. Now, if you see here, when mu stands for the population mean, so this is the population, this is the mean value which is being represented. So this is mean, right? And the moment you calculate this, it tells you the average deviation from the value here. Now let's go ahead and see how we can calculate this on Excel again. Now if we just take the same data set of extracting the marks, so I'm going to calculate the mean deviation. So mean deviation is given by the formula of average deviation. Yeah, this is the first one, AVEDV, it's the average deviation. It is the averages of the absolute values, right? Average deviation of the marks obtained by the students. So 14.12 is the average deviation. There is nothing but your mean deviation. So this is how we calculate the standard deviation and mean deviation using Excel. So by the end of the session, we have learned the measures of dispersion, range, interquartile range, standard deviation, and mean deviation. Now, this is a mechanism to obtain all the descriptive statistics at a go. By the next session, I'll be teaching you how to extract the descriptive statistics at a go on Excel. Till then, happy learning. Extraction of descriptive statistics in Excel. In the last sessions, we have seen how to obtain the values of mean, median, mode, standard deviation, that is all the measures of central tendency and dispersion by using the inbuilt function of Excel. Now, in this particular session, we are going to learn how to obtain all the descriptive statistics at one go by using an add-in in Excel. Without delay, let us go into that particular session, into that particular problem. I have a problem statement over here. The problem statement is to obtain the descriptive statistics of salary obtained by the workers. Now let's go ahead and see how can you obtain the descriptive statistics of the salary of the workers. To do this, I'm referring to the data set of salary right now. This is the data set. So I do have the salaries of the 20 workers. Now I wanted to extract the mean, median, Q3, Q1, maximum, minimum, and the count. Okay, now let's see how can we do this. If you just go to the data tab in the Excel, you'll be seeing an adding function called data analysis. So that is not enabled for me. I will show you how it is to be enabled. Go to the files, go to more, click on the options here. The moment you click on the options here, it will take you to a add-ins, And the moment you click on add-ins, just scroll a little. Yeah, you'll be seeing Excel add-ins. Click on go. You can see something called as analysis toolpack. Okay, only select this one. Check that box and then click OK. The moment you do this, you can see the data analysis toolpack which is being enabled over here. Click on this data analysis. It will give you what are all the functions it can do, like ANOVA, correlations, or what are all the statistical functions it can do. So you can see something called descriptive statistics here. Click on that and click OK. The moment you click OK, it will ask you on which values do you want to extract the descriptive statistics, right? So hence I want the descriptive statistics on the salaries of all these 20 workers, only on the salaries, because workers is a serial number, right? So hence what I'm doing, I'm selecting from the label part. As I am selecting from the label part, I have to enable this labels option over here. So I'm just clicking on labels in first row. Now out of these options, so I want the output to be in the new worksheet. And out of this, what is that I require? I require the summary statistics. So hence I'm enabling this and click OK. The moment I click OK, it will take you to a new sheet which comprises the descriptive statistics. See, it is obtaining the mean, standard error, median, mode, standard deviation, variance, kurtosis, skewness, range, minimum, maximum, sum, and count. Right? So this is how we can obtain the descriptive statistics at one go by using the Excel. I hope you all enjoyed this session of descriptive statistics. See you in the next session. Till then, happy learning.